So whatever. Okay. So we're still talking about chapter 5, and we're dealing with probability. Okay. Do we talk about and versus or? No. Okay. All right. So we'll talk about and versus or. All right. Then let's. So let's say we've got. Got something like this, okay? Okay, so let's say you go to, you're going to take a survey. We'll go to Iowa just for fun today, all right? Okay, and then we're going to go, we're going to say, hey, do you self-identify as liberal, moderate, or conservative? Okay. And then we'll also say, do you live in an urban area, okay, as urban as Iowa gets, or do you live in, we'll say urban or city, or do you live in rural Iowa, all right? Okay, and I have no idea the demographics, what these numbers look like, so I'm just gonna make some numbers up here, okay? All right. How much of Iowa lives in the city? We'll say we got a sample of 220 people. So we'll say 100 in urban and 120. I have no idea. I'm just making this up. Okay. And we will say how much of Iowa is conservative? Huh? We'll say 100, and we'll say 50 and 70. Just making stuff up here. Don't get me in trouble here. All right, 50, 20. I'm just making up numbers here. 30 and 20. That gives me 20 and 80. Okay, now I've painted a poor picture. This is not what Iowa looks like. But okay, so anyway, we can just ask questions like, what is the proportion? What is the, if we select someone at random, what is the probability that this person is urban? And you would say, so we're going to pick someone at random, right? Pick someone at random from our table. Okay, and okay, so what would our answer here be? So we can consider every single person a simple outcome, right? All 220 people have equal probability of being selected. So what's the probability that I end up selecting someone from an urban or city environment? 100 out of a total of 220 possible selected people, okay? All right, we can ask, what's the probability that someone in Iowa self-identifies as having liberal political views? And this would be 70 out of 220, okay? And then, and then we can extend this, okay? And this is where the and comes in, okay? So we could say, what's the probability that someone is urban and has liberal views? Okay, I will answer this. We have, yes? 50 out of 220. Thank you for lifting my spirits here. All right, and okay, so we have urban and liberal, all right? And then lastly, we will say what's the probability that someone is from an urban environment or self-identifies as liberal, okay? And so the or is a little bit tricky. So I think these are all straightforward, right? We just take kind of the row total or the column total, or in this case, we look at the cell where they've overlapped. I just want to make sure we don't have any questions on these. Okay, and then for the last one, urban or liberal, we'll go through and I'm going to put little check marks next to the boxes that qualify, okay? So for those who are urban, we've got these 50 urban liberal people, we have these 30 urban moderate people, and these 20 urban conservative people, okay? But also, people who qualify are also just people who are liberal in a rural area, okay? All right. This group of 20 and this group of 80 do not qualify, okay? So the total number of people who are urban or liberal would be 50 plus 30 plus 20 plus 20 over 220, or we have 120 over 220, okay? We have a generalized formula, okay, that says the probability of two events A or B can be expressed as the probability of A plus the probability of B, but if you do that, you have to subtract off any overlap. Okay, so here, if we said, what is the probability of urban or liberal, we would say this is equal to the probability of urban plus the probability of liberal minus the probability of urban and liberal. Okay, and so probability of urban we've determined earlier to be 100 out of 220. Probability of people who self-identify as liberal would be 70 out of 220. And then we're going to subtract off any overlap, okay? Because if I just naively said, I'm going to add up 100 over 220 plus 70 over 220, I would end up getting 170 out of 220. And we could see that that doesn't match our answer over here. And what's going on is that number 100 includes all three of these numbers, okay? This number 100 is basically these three numbers together. And this number 70 is these two numbers together. So we've effectively, if I were to add 100 plus 70, I would have double counted this group of 50, okay? So I need to subtract off just one of those, okay? I don't need to subtract them both off, but because I've double counted, I gotta just subtract one of those 50s off. Okay, and so if I do that, indeed here I get 120 out of 220, which is correct. Man, this is killing me. Okay. It's already February, you guys. Super Bowl's next week. Valentine's Day's in 2 weeks. I don't know. Oh, President's Day. We get President's Day this month also. What a great time to be alive. Okay. All right, so we've got that. Let's let me, okay, actually, let me, I shouldn't have done that. Okay, I'm going to just copy this, kind of. Okay. All right, I got to recreate this table. All right, so, Okay, so we got liberal, moderate, conservative, urban, city, no, rural. And I forgot what my numbers were. What did I say? Is this right? 50, 30, 20. So that means this is 20, 20, 20, 20, 80. Okay. All right. So we've taken care of that or business. Okay. There's this concept of mutually exclusive. Okay. Mutually exclusive means. Oh, I've already covered this, right? Yeah. Okay. So then. So all right. We'll just ask two questions. Okay. Is L and U mutually exclusive? And then let's say is L and M. All right. Are L and M. Are L and U mutually exclusive, and are L and M? Okay. So are L and U mutually exclusive? The answer to that is no. Okay, because there's some overlap between you can be both liberal and in an urban environment. Okay. So this is no. But are L and M mutually exclusive? Can someone self-identify as liberal and at the same time self-identified as moderate? No, they couldn't have, so they are mutually exclusive, okay? Yeah, over time, people can change their political views. That's not a problem, okay? That's that happens. I always, I don't mean to say anything political here, but I always find it interesting that it's like it's a bad thing if a politician changes his or her mind about something, but I think in regular life, it's good to be open-minded about things, right? And when you learn something new, you're like, oh, well, I've changed my opinion on the matter, but anyway. But in politics, they call that flip-flopping, and apparently people don't like that. Okay. Okay, so L and M would be, in this case, mutually exclusive. So there's a special case of the OR rule, okay? And that is the probability of A or B is equal to the probability of A plus the probability of B, okay, when A and B are mutually exclusive. Okay, and that it's actually quite easy to see because what mutually exclusive means that the probability of A and B is equal to what? 0. Okay, mutually exclusive means A and B cannot happen together. The probability of A and B is equal to 0. So we can see how the general probability of A or B, which is always true as A plus probability of B minus probability of A and B. Okay, so this thing is always true. For the special case, A and B just becomes 0, and we're left with this. Okay, right? So if A and B are mutually exclusive, this is 0. Okay. that good? All right, great. Being president's got to be the worst job in the world, man. It's like, no matter what you do, everybody's hating on you. Not everybody. Half of the nation at any given moment. Okay, we have what we call conditional probabilities. Conditional probabilities. Okay, so this, what this means is that we are talking about the probability of an event if we know another event has happened, okay, or if we know something else is true, okay. This is the probability of an event if we know some other event or outcome has happened. Okay? So, silly examples would be if I said, I've picked a random student from an elementary school, okay? Picked a random student from the elementary school and I said, guess the, what is the probability that this student is a girl? If you don't know anything about it, your best guess is probably 0.5, okay? Now I can give you some other information and I can say, this student's favorite color is pink, okay? And then so, what is the probability that this student is a girl, okay? That's probably going to change your answer. If the student's favorite color is pink, probably more likely to be a girl, okay? Now, yeah, boys' favorite color could be pink too, but, if in elementary school, if a student's favorite color is pink, probability that this student is a girl is no longer 50%, but we would have changed the answer to probably 90% or 80% or something like that, okay? So this is, that would be an example of a conditional probability. The probability of an event if we know something else is true, okay? So the example, pick a random elementary school student. Elementary school student. What is the probability the random student is a girl? 0.5, okay? Probability the random student is a girl if we know the student's favorite color is pink. Now we change this, maybe 0.9. I have no idea, okay? All right, so we don't want to have to write this out like this, so we have a shorthand for this, okay? And we would say probability of girl, I can't tell if that's a capital or lowercase g, girl given pink, okay? And so we write this vertical bar. The vertical bar we read as given, okay, which means, if the event pink is true, okay, and we would say this is equal to 0.9. Okay, so let's take a look at our pretend Iowa table. And okay, so then we're going to say, what is the probability that someone is conservative given if we know this person is from a rural area. Okay, so the way we would answer this, okay, so once we put this vertical bar here, so I'll write this is probability of conservative given rural. This is how we read it. This says if we know that the selected person is from a rural area of Iowa, okay, we no longer have 220 people to deal with. We only have to worry about these 120 people in the rural parts of Iowa. Okay? So our denominator is not 220 like it was in all of the other examples. Our denominator is going to be 120. What's going to be in the numerator? $80, right? Okay? Because I would not write 100 because the 100 includes these 20 people who are conservatives in an urban area, okay? And that means, and that's not possible because I'm limiting myself to these 120 people. So effectively, I've just isolated my table just to this single row once I have this given part. And I'm saying, okay, out of 120 people, how many are conservative? 80 of them are. Okay. All right, go ahead and try to answer this question. Is this the same thing or is this different? So they look similar, but this is different, okay? This would be the probability of rural given conservative. Okay, so we want to know, so what this says is, okay, I am limiting myself just to these people who have identified as conservative, okay? So only these 100 people. I'm not looking at these 50, I'm not looking at these 70. Everyone else doesn't matter, just these 100 people. Out of these 100 people who've identified as conservative, how many live in the rural parts? 80, okay? So our answer here is going to be 80 out of 100. Are we feeling okay with this? Yeah? Okay. So let's try a thing here, okay? All right. So if I ask, what is the probability that a person is male if we know the person, I don't know, likes to eat pizza? Okay? All right. So let's see. How is this expressed? How is this expressed? Okay, so your answer choices are probability of male and pizza. B is probability of male vertical bar pizza. Probability of pizza vertical bar male. Probability of pizza and male given, no, we'll just say that. Okay. Okay, ready, go. Oh, is this working? Oh yeah. Oh my gosh, everybody's clicking away. It's like Too easy, too easy. All right. Okay, we'll just say 5 more seconds here on this one here. And okay, and the answer is the answer is that. Okay, good job. 133 of you. Okay, great. All right, let's try a problem here. Okay, so we will say there are 150 people in the classroom. I'm making this up. Okay, and we'll say 80 of them are male, and 75 out of 80 males like pizza, and a total of I don't know, 130 people like pizza. Okay. All right. So I'm going to ask a few questions, all right? So I'll say, what is the, okay, if we randomly select a person, what is the probability this person is female and likes pizza? Okay. Now I have to actually think of the answer myself. Okay. Oh gosh, my brain. Okay, I got the answer. All right. The answers, your answer choices are okay, are you guys ready? We're gonna run the and then I guess I should say we're assuming you're either male or female only. Okay, we'll so. Okay, so we'll say 10 more seconds. Just click something. Okay, here we go. All right, so let's talk about this one. How do can I just copy this slide like that? Can I bring it over here? Hey, look at that. Okay, all right, so let's, so for here, I'll draw a little picture, okay? Okay, so this is our classroom with 150, and okay, so we've got 80 males, which leaves us with 70 females. Okay, and then we've got 75 like pizza, and 5 don't. Okay. All right, and then we have a total of 130 people liking pizza, right? So I don't know. Okay. So this 75 plus whatever over here must add up to 130, right? So we get 55 here. So how many don't like pizza over here? That would be 15. Okay. All right, so what is the probability that this person, if we're picking one person at random out of 150, all 150 are equally probable. So we got 55 out of the 150 who, this would be the probability of female and pizza, okay? So our choice here is answer B. Okay? So those of you who selected C, the answer that you are going for is probability of female of pizza given female. Darn it. Yeah, okay? So that's if I selected a female, then I'm down to just 70 people. Of those, how many like pizza? 55 out of 70, okay? It's probably higher than that. I feel like everybody likes pizza, right? No? Who said no? Okay, so we got that. All right, we shall continue on here. Okay, so then we have this idea of independence. Okay? So independence, these mean if two events are independent, then the outcome of one event has no influence on the outcome of the other event. Okay, so what this means is that if we talk about given probabilities, if we got events, let's say events A and B are independent. Okay, so what this means is that the probability of A, so the probability of event A is probability of A, right? Okay. So, you know, probability of A is probability A, okay? And then we'll say the probability of A given B, so the probability of A given B, so if we know that B has happened, what is our probability of A if we know that B has happened? This is the probability of A, okay? So if they are independent, the probability of A given B is just the probability of A. What this says is that even if we know B has happened, the probability of A happening is just the probability of A. Okay, so so if we think back to our elementary school example, and we say, you know, I picked a student at random. What's the probability this person's female? You'd say 0.5, and I'd say, oh, but this student's favorite color is pink. That probably changes your answer. You'd say, oh, now I would guess that the probability this person's a girl is, you know, higher than 0.5. Okay, like 0.9 or something. Okay, but if the piece of information I give you is this person is left-handed, okay? You know, would that change your answer about whether the probability of this student being a girl? No, okay? Because knowing that a student is left-handed doesn't make this student more or less likely to be a girl. So in that case, being left-handed is independent of being a girl. So the probability of being a girl, given if we know that the student is left-handed, doesn't influence our answer. It's just our original answer of, well, I still think the student has a 0.5 probability of being a girl. Okay, so I guess I could write that down. Okay, so probability of, you know, this is a girl, is equal to 0.5. Okay, if we know the student is left-handed, okay, then we have probability of girl given left-handed, okay? But this is still 0.5. Because left-handedness provides no additional information. Ooh. Sorry that my this slide is like a Franken slide with a text in all of these different places here. Okay, so so keep that in mind about independence, and I'm going to ask you a clicker question on independence here. Yes, we have a question before the question. The answer for this one was B, 55 out of 150.
Sorry, I was saying with the given probability.
Yeah. Okay. All right. Oh, whoops! I didn't mean to do that. Do you guys have all this text down? More or less? No? Okay. So I will say if events A and B are independent, could they, I'll say, are they mutually exclusive? Okay, and then so your answer choices are A and B are mutually exclusive. B is A and B are not mutually exclusive. And C, whoops, is A and B could be or may or may not be. May or may not be mutually exclusive. Okay? We would say need more info. Okay, are you guys ready to answer this question? Here we go. This is, I don't know, I gotta get rid of this could. Okay, if A and B are independent, are they mutually exclusive? They are not, they may or may not be. Okay, just think about what it means to be independent, what it means to be mutually exclusive. Okay, we'll say 10 more seconds here. Okay, get your clicks in. Here we go. All right, let's see. This, I think the graph is going to look interesting here. We're very divided on the answer here. Oh, but show me. Here's our result chart. And the correct answer is B. Oh, okay. Let's talk about this. Oh, this is the wrong one. How do I get this thing? Oh, come on. All right. Where's my Okay. So let's talk about this thing. All right, what does it mean to be independent? If A and B are independent, then that means the outcome of A has no influence on the outcome of B, right? If A and B are independent, then the outcome of A has no influence on the outcome of B. Sorry, I'm writing quickly, so my handwriting is sloppy. Okay? All right, if A and B are mutually exclusive, what does that mean? Then that means if A happens, then what? B is impossible, right? Then B becomes impossible. So that means A has influence on B if they're mutually exclusive. So A influences the outcome of B. Okay, so mutually exclusive events cannot be independent, okay? Or independent events cannot be mutually exclusive. Okay, and vice versa. Okay, so if we know two events are mutually exclusive, we know they are not independent. If two events are independent, we know they are not mutually exclusive. Okay, we'll end there. We'll see you guys on Wednesday, and that's it.